So this is a newest device we developed. Again, two LEDs and two PDs, and you will be testing this device on Friday. Two LEDs and two PDs. So this is one of the applications. There's something called a flap. Flap is a piece of tissue we move from one part of the body to another part of the body. So it's commonly used in reconstructive surgery to cover defects caused by like trauma, cancer, or other conditions. And the most important thing for this flap to survive is to make sure this flap is perfused with blood. We need to be able to restore blood supply to flap. So that can be monitored by looking at the StO2, the tissue oxygen saturation. So I'm going to move up to the next slide. It's bloody. Just a heads up, it's bloody. Okay, we did this on pigs. So we move flap to another body part. Then we insert our probe into this flap. What we see here is that we will manually blocking the artery, so there's no blood going into the flap. Then we release the blockage so that blood can be restored into the flap. So what we show here, which is the black line. So at the baseline, when there's blood, we have StO2 around 65%. Then when you block the artery, then you see StO2 goes down. Then when you resume blood supply, StO2 goes back. So you can induce this kind of ischemia and reperfusion cycles. You're very sensitive to detect StO2. So just one of the applications using this optoelectronic probe, we can monitor tissue oxygenation. And we can even have an array. Go ahead.
Why was that probe implanted? Like, is the flap fully on the inside instead of like a graft on the outside?
Let's see where it is. It's inserted into this flap. So because our light, like red and infrared, has limited penetration depths. So depending on where you want to monitor, you have to insert to specific locations because light doesn't travel that far. And we can